Unit 7, Atmospheric Pollution. Air pollution is the introduction of chemicals, particulate matter, or microorganisms into the atmosphere at concentrations that are high enough to harm plants, animals, and materials such as buildings, or to alter ecosystems. Ground level pollution occurs in the troposphere, which is the bottom layer of the atmosphere, and that's generally what we refer to when we say air pollution. There is natural air pollution that comes from volcanoes and wildfires and that kind of thing, and then man-made air pollution that comes from cars and factories. While air quality in the U.S. is getting better, it is getting worse in places like China. And since the atmosphere is a global system, one country may experience another's pollutants. The atmosphere is considered a global commons. The Clean Air Act of 1970 identified the following as significant threats to humans, ecosystems, and structures. So we're going to go over those criteria air pollutants on the next few slides. Sulfur dioxide comes from the combustion of fuels containing sulfur. It can lead to acid rain. SO2 is a corrosive gas. It reacts with oxygen to form sulfur dioxide, and it also can be released during volcanic eruptions and forest fires. Nitrogen oxides, generally described as NOx. Nitrogen monoxide is a colorless, odorless gas, while nitrogen dioxide is a pungent, reddish-brown gas. Cars and fossil fuel combustion are the primary man-made sources. Natural sources do include forest fires, lightning, and bacteria action in the soil. This does play a role in forming tropospheric ozone and photochemical smog, which we'll get to later on. The carbon oxides contain carbon monoxide, which is a colorless, odorless gas that's formed during incomplete combustion. It's a common emission in vehicle exhaust, and it is a dangerous indoor air pollutant. It can bond to hemoglobin, interfering with oxygen transport, which can lead to death if the person doesn't get to a ventilated area. Carbon dioxide is a colorless, odorless gas that is formed during complete combustion of fossil fuels and is considered a greenhouse gas, but is not considered a criteria air pollutant. Particulate matter can be solids or liquids suspended in the air. They come from the combustion of wood, animal manure, fossil fuels, especially coal and oil, and biofuels. Diesel gives off more particulate matter than gasoline. It can also form from road dust, rock crushing operations, volcanoes, forest fires, and dust storms. Mount Tambora in 1815 in Sumbawa, Indonesia, blew 13,000 feet high and killed 10,000 people. It threw up enough gases, dust, rock, and ash that it caused the summer of 1816 to be called a year without a summer because it was chilly and gloomy. And there were crop failures and famine as far west as the United States and Europe from the particulate matter thrown up by that volcano. Particle size ranges from 1/100th of a micrometer to 100 micrometers. Your nose can filter out anything larger than 10 micrometers. PM10 are smaller than 10 micrometers and can get into your respiratory tract, whereas PM2.5 tend to be more toxic and get deeper in the tract because they're so much smaller. Particle matter scatters and absorbs sunlight. Large amounts can reduce incoming solar energy. And haze caused when particulate matter goes up, forms from air pollution and scatters light. Photochemical oxidants are secondary pollutants. They're formed as a result of sunlight acting on compounds such as nitrogen oxides and sulfur dioxide. It's harmful to plant tissue, human respiratory tissue, and construction materials. Ozone is the most abundant photochemical oxidant in the troposphere. It is harmful to plants and animals and causes asthma and emphysema. Smog is a mixture of oxidants and particulate matter. Photochemical smog is also called Los Angeles type smog or brown smog, and it's mostly composed of oxidants like ozone. Sulfurous smog or London type smog is also called gray smog, and it's mostly sulfur dioxide and sulfate compounds. The atmospheric brown cloud is a combination of particulate matter and ozone derived primarily from combustion of fossil fuels and biomass. It is causing gradual melting of Himalayan glaciers as particles absorb sunlight and warm the air over the glaciers, but overall it's reflecting sunlight back to space, having a cooling effect on the atmosphere, and its effects are found as far across the Pacific as the western United States. Lead and mercury are persistent chemicals, meaning once you absorb them in your body, they become part of you. You can't get rid of them. Lead occurs naturally in rocks and soil. It's found in small amounts in oil and coal. It used to be added to gasoline in the United States to improve engine performance, but that was banned in the 70s and is no longer used in the United States, although it may be used in other countries. Lead compounds released in the air travel with prevailing winds and are deposited on the ground by rain or snow. They can even make it all the way out to polar regions. Like I said, it was phased out of gas in the United States in the 70s. There is a global phase out underway. Lead-based paints are no longer used in the U.S., but if old paint chips, it can release chips or dust with lead in them that could be ingested. And lead is toxic to the central nervous system, which can affect learning and intelligence. Mercury is also found in coal and oil, causing central nervous system damage. It is released primarily from the combustion of fossil fuels. It's found especially in coal. Coal-fired power plants are the largest uncontrolled source. It's regulated by the EPA through the Hazardous Air Pollutants Program, and the concentrations in air and water have increased dramatically. Bioaccumulation in fish has increased. Release from waste incinerators has decreased. Coal-fired power plants are the largest uncontrolled source of mercury. Volatile organic compounds are compounds that become vapors at typical atmospheric temperatures. Many of them are hydrocarbons like gasoline, lighter fluid, dry cleaning fluid, oil-based paints, and perfumes. They are naturally given off by conifer trees in the form of terpenes. They play an important role in the formation of photochemical oxidants like ozone, but they are not hazardous alone by themselves. Primary pollutants come directly out of the smokestack, exhaust pipe, or natural emission source, and they include chemicals like carbon monoxide, dioxide, sulfur dioxide, the nitrogen oxides, and many VOCs. Secondary pollutants are primary pollutants that have undergone transformation in the presence of sunlight, water, oxygen, or other compounds. So they've undergone a chemical reaction. It does not occur as rapidly at night due to the lack of energy from the sun, or in dry environments due to the lack of water. They tend to include ozone, sulfate, and nitrate. Volcanoes release sulfur dioxide, particulate matter, carbon monoxide, and nitrogen oxides. They can create acid precipitation after an eruption. Lightning strikes can also create nitrogen oxides from atmospheric nitrogen. Forest fires release particulate matter, nitrogen oxides, and carbon monoxide. Like I said, living plants release volatile organic compounds like ethylene and terpene. In fact, that's what causes the natural smog, and that's how the Blue Ridge and the Smoky Mountains got their names. Also, large-scale agriculture releases particulate matter during plowing. Human emissions are monitored, regulated, and controlled by the EPA. On-road vehicles are the largest source of carbon monoxide and nitrogen oxides. Electricity production by coal is the largest producer of sulfur dioxide, and particulate matter comes from fires, road dust, and electricity generation. The Clean Air Act requires the EPA to establish standards to control pollutants that are harmful to human health and welfare. Human health includes elderly, children, and sensitive populations like people with asthma. Welfare refers to visibility, status of crops, natural vegetation, animals, ecosystems, and buildings. National ambient air quality standards specify concentration limits for each air pollutant not to be exceeded over a specified amount of time. All 6 criteria air pollutants have decreased in the U.S. over the last 20 years. Only ozone and particulate matter regularly exceed these limits. The Black Triangle is the most polluted area in the world due to the high use of sulfur coal. This is found between Germany, Poland, and the Czech Republic. Uh, it causes human health problems like respiratory illnesses, and you can see from the picture the ecosystem damage it's caused to surrounding forests. China usually dominates the list of most polluted cities. Visibility may be reduced by as much as 20% because of particulate matter and sulfur dioxide. Photochemical smog and ozone are still air quality issues in the United States. The EPA reported in 2010 that 50 regions in the United States did not comply with maximum allowable ozone concentration in the air. And if you can notice from this map, the north central area of Alabama is included in that. There are several steps in the chemical process that forms photochemical smog. Has to be in the presence of sunlight. Nitrogen oxides will form ozone. When sunlight intensity decreases, nitrogen monoxide and ozone combine and reform into oxygen and nitrogen dioxide. If you notice at the bottom there, when volatile organic compounds are present, they combine with nitrogen oxide and ozone, and then they can't be broken down and they accumulate. Volatile organic compound evaporation increases with temperature. Nitrogen oxide emissions increase on hot days as people use more air conditioning. And chemical reactions proceed more rapidly when temperatures increase. A thermal inversion occurs when a relatively warm layer of air at mid-altitude covers a layer of cold, dense air below. Warmer, less dense air from a warm front or upwelling moves in over that cooler, denser air mass. Whenever radiation from the surface of the Earth exceeds the amount of radiation received from the sun, such as at night or in winter, this is considered a thermal inversion. Tianjin, China, in 1998 experienced a thermal inversion that led to the deaths of 11 people. It was a cold snap, and the central heating for the city had been turned off, so many people used their household coal-burning stoves, which led to incomplete combustion, releasing carbon monoxide and poisoning thousands of people. Indoor air pollution is a significant hazard, particularly in developing countries. 90% of deaths attributed to indoor air pollution are in developing countries. In developing countries, indoor burning of wood, charcoal, dung, crop residues, coal, etc. Release carbon monoxide and particulate matter. Like I said, when carbon monoxide is breathed in, it displaces oxygen in the blood and can lead to coma and death. Exposure to indoor air pollution from cooking and heating increases the risk of respiratory infections, pneumonia, bronchitis, and cancer. In developed countries, indoor air pollution is greater than outdoor air pollution. 11 of the common air pollutants are higher inside than outside. It's greater in vehicles than outside. And people spend a lot more time inside. 70 to 98% of their time is spent indoors or in cars. Who's at the greatest risk? Children under 5 and the elderly, people that are sick, pregnant women, people with respiratory disorders or heart problems because it puts strain on the heart. Smokers, factory workers, example, the picture of these children working in this urban slum, which I'm sure their room has little to no ventilation. And this increases the risk of respiratory infections, pneumonia, bronchitis, and cancer. 4 of the most dangerous indoor air pollutants are carbon monoxide, volatile organic compounds like formaldehyde, radioactive radon-222 gas, very small particles like asbestos. Other air pollutants, tobacco smoke, pesticide residue, lead particles, living organisms like these dust mites that are pictured here, excrements like cockroach droppings, or airborne spores of molds and mildew. Here's an example of a few things you can find in your home. Notice the arrows pointing to some important things to know here, like asbestos, carbon monoxide, radon-222, formaldehyde. Asbestos is a long, thin, fibrous silicate mineral with insulating properties. It's an excellent fire retardant. People who mine asbestos have high rates of asbestosis, which is a scarring of the lungs caused by inhaled fibers, which is pictured, that's what the middle picture is of a scarred lung there. And then I've got a picture of what asbestos looks like on the left, and then on the right is a picture of it under an electron microscope, and you can see the thin silicate fibers. Insulating materials are dangerous if their fine fibers are inhaled. It can cause lung cancer. Asbestos is no longer used in the U.S., and removal has to be done under extremely controlled conditions to capture all those little tiny fibers so they aren't inhaled. Radon-222 is a naturally occurring radioactive gas that is produced by the decay of uranium. It has a half-life of 4 days, and it becomes radioactive polonium-210. It exists in granite and other rocks and soils. It can seep into homes through cracks in the foundation or soil or drinking water. The radon or polonium can attach to dust particles where it is inhaled and then settles in the lungs, and it is the second leading cause of lung cancer after smoking. Increasing ventilation in the home and sealing cracks in the basement are the best ways to bring down radon levels. Sick building syndrome are buildings that are sealed very tightly and insulated, and it allows toxic compounds and pollutants to build up in a tight airspace. Indoor levels of VOCs, hydrocarbons, and other compounds can be quite high in these buildings. It can cause headaches, nausea, throat or eye irritation, and fatigue. 4 reasons for sick building syndrome identified by the EPA are inadequate or faulty ventilation, chemical contamination from glues, carpet furniture, cleaners, copy machines. Outdoor chemical contamination can be brought indoors through ventilation, and biological contamination from indoors, such as mold and mildew spores, or it can be brought in from the outdoors, such as pollen. Some solutions to indoor air pollution are like this turbo stove here in India that uses cleaner burning fuel. In developed countries, using adjustable fresh air vents for workspaces, circulating air more frequently, banning indoor smoking, using less polluting cleaning agents, paints, and other products. The best way to control pollution is to prevent it. The best thing is using fuels that contain fewer impurities, increasing efficiency, increasing conservation measures, or developing fuel sources not dependent on combustion. Fluidized bed combustion removes sulfur dioxide from coal exhaust during combustion by burning granulated coal in close proximity to calcium carbonate. Calcium sulfate is produced and can be used in the production of sheetrock. Any sulfur dioxide that does escape can be captured through the ventilation system. Nitrogen oxides are produced in almost all combustion processes in the atmosphere on Earth, since it's composed of 78% nitrogen. Lowering the burn temperature and the amount of oxygen during the process can reduce nitrogen oxide emission. However, this can lead to incomplete combustion, resulting in reduced efficiency and increased particulate matter and carbon monoxide emissions. Removing lead from gasoline and requiring catalytic converters such as this one on cars has reduced nitrogen oxide emissions. It also has cut down on carbon monoxide emissions, and as you can see, you have water, carbon dioxide, and nitrogen as your emission. The simplest method is gravitational setting of smokestack of particles. However, that doesn't get rid of the problem, it just sends it somewhere else. 3 of the following methods all require electricity to operate. Baghouse filters are fabric filters that allow gases to pass through but trap particles. It's almost 100% effective. Electrostatic precipitators use an electrical charge to make particles stick to the negatively or positively charged plates so they can be removed. Scrubbers use a combination of water and air that separates and removes particles, and they become liquid sludge at that point. The only way to reduce smog is to reduce the primary pollutants that create ozone. Example, reducing volatile organic compound use, especially in hotter months during the day, like gassing your car up at night, mowing your lawn at night, that kind of thing. Ways to reduce volatile organic compounds, like I was saying, reduce or restrict the amount of gasoline you use during the day, restricting dry cleaning fluids, lighter fluids, reduce of wood burning stoves or fireplaces, and reducing the number of bakeries. Believe it or not, as bread rises, it gives off volatile organic compounds. An amendment to the Clean Air Act implemented between 1995 and 2000 called the Acid Rain Program has allowed 3,000 power plants to significantly reduce their sulfur emissions. If a company emits more sulfur dioxide than their allowance permits in a year, they are charged a fine. However, sulfur allowances can be bought and sold on the open market, and allowances have been gradually decreased every year. And you can see from this graphic, some places have done a better job than others of reducing their sulfur dioxide emissions, whereas others have increased. Acid deposition is much less of a problem than it used to be. It can be more of a regional air pollution problem. All rain and snow is somewhat acidic due to water combining with carbon dioxide to create carbonic acid, which tends to lower the pH from 7 to 5.6. So acid deposition refers to a pH lower than 5.6. And you can see from these graphics the good job that has been done on reducing sulfate and nitrogen deposition, and that's why acid deposition is not the problem that it once was in the United States. So sulfuric acid, sulfur dioxide, nitrogen oxides react with water and oxygen to form sulfuric acid and nitric acid. Sulfuric acid and nitric acid then break down, producing sulfates, nitrates, and hydrogen ions. And those hydrogen ions are what cause the pH to drop in bodies of water. So direct effects of acid deposition can include lowering the pH of lake water, decreasing species diversity of aquatic organisms as it lowers the pH and their range of tolerance is the threshold has gone past. You can see from this picture it damages statues, monuments, and buildings. It can also lower crop yields as it damages plants. Some indirect effects is the acid actually mobilizes metals like aluminum that are found in the soils and releases them into the surface waters, or it allows plants to take them up, causing the death of the plant. Decreased pH affects food sources of aquatic organisms. It leaches soil nutrients again, so those they wash off into surrounding bodies of water, and you can see from this picture the forest damage that it can cause. Noise pollution. Health problems include loss of hearing, high blood pressure, and stress from excess noise. It can also cause loss of sleep, which may lead to decreased productivity. Decibel is the most common unit used to measure loudness, and it's abbreviated little d uppercase B. The quietest sound the human ear can hear is represented by 0 decibel, so this is an arbitrary scale. For each increase in decibel intensity, the decibel level is 10 times higher than the previous level, so it is a scale of magnitude. And a sound of 120 decibels is at the threshold of pain, and permanent deafness may come as a result of continuous exposure to sounds over 120 decibels. And you can see from this graphic some common everyday noises and what their decibel levels are.